You want to find the volume of the solid obtained by rotating about the x-axis, the region under the curve y equals x to the 1/4 from 0 to 5. Well, first step is to graph y equals x to the 1/4 on the Desmos graphing program. So you just want to get a good look at it. And so if you do that, let me say I did that here. So I put in y equals x to the 1/4. I also put in x equals 0 and x equals 5 because that's what they said from 0 to 5, right? This is 0. These are, you can put these in right now. These are 0 and 5. Okay. And here's the graph. So here's the function, in red, y equals x to the 1/4 from 0 to 5. So we're talking about this region right here. Okay, and we want to rotate that. Notice we're rotating that about the x-axis. This is the x-axis, as you know. So we're going to rotate, and it's going to come down here, and we're going to get this three-dimensional shape. In fact, let me show it to you real quick, and then we'll do the problem. So here it is on CalcPlot 3D, which you have access to as well on the homepage of our Canvas course. So as I put the function in, x to the 1/4, and you can see it there on the 3D graph up above on the 2D. This one's nice, shows both the 2D and the 3D. Then I can rotate it. Here we go. I'm going to rotate the region. See it rotating around there. And there it is. There's the three-dimensional shape we're talking about. We're trying to find the volume of that shape. Isn't that nice? It kind of shows it. Not only that, you can, how are we going to do it? We're going to do it by filling it up with washers. So now, there it is. Let me rotate again. Now I'm going to rotate the washers. See those washers right there? I'll just leave it partway rotated. We're going to estimate the volume. Oh, well, we're actually going to find the exact volume. We're going to find the exact volume of that three-dimensional shape by using these. Actually, these are discs. Disc washers. Washers are just discs with a hole. So these are discs. But see how if we only use four discs, see how that's only four. We're not going to get the exact volume. But if you let the number of washers go up, see, I'm raising the number of washers now. As the number of washers goes up, see that? It starts to get more and more close to the actual volume. You can see it's estimating the volume down there for us. 23.4237. See that down there? Um, so, in fact, let me bring that over where I can write on it, and we'll use that, and I'll put it in up here, and then we'll do the problem. Okay, so there it is. So you can see down here, it's giving us an estimate, which is helpful. It's not going to be the exact answer. You can't type that in, it won't take it, but it's an estimate of that 3D shape, which is made up of a bunch of disks. All right. So anyway, how do we do it? So step one, we get the graph. Got it. Step two, go to the notes on the home page. The home page notes. These will be really helpful to you. And here we go. So coming up here, here's the notes. We have the dishwasher method. We have four types. We have about the x-axis, about the y-axis, and then we have about something parallel to the x-axis or parallel to the y-axis. In our case, we're rotating about the x-axis. So I'm gonna go with this one, rotating about the x-axis. How do you do it? Well, there's the volume formula, integral pi times the integral from left to right, capital R squared minus the R squared dx. So I go, okay. So it's going to be the volume will equal pi integral from left to right of capital R squared minus little r squared dx. Okay. So let's just do that formula, then I'll talk about why is that true. So it's pi integral left to right. That's pretty easy. You can see right on here. This is the left. This is the right. It's going from 0. This is really 5 here. 0 to 5. The left side, right side. So 0 to 5. What is capital R squared? Capital R squared, you can see in the diagram. I put this in the notes for you. Capital R right there is the height from the x-axis all the way up. Now, the little r is if there's a bottom part. Now we don't have a bottom part. We just have a top and then it comes all the way down here. So our little r is going to be 0. So little r is like the inner radius and capital R is the outer radius. We only have a outer r, capital R, outer radius on this one. Our little r will be 0 on ours. So capital R is up to there. So let's do it. So capital R is going to be how far from the axis up to the curve. That's capital. Let's just put it on our thing right there. So here's the actual washers that we're going to be the disc we're going to be putting. There's a disc. We're going to be stacking up those discs. And here I didn't draw that the best. It wasn't terrible, but I guess that's not a lot better. Anyway, whatever. There we go. So there's one of the discs, and we're gonna want to find the volume of that disc. What is it? Well, we have the outer radius, capital R. That's how far up to the curve y equals x to the 1/4. That's going to be y equals x to the 1/4. That's how far from the x-axis up there. There it is. X to the 1/4 of capital R is x to the 1/4. But then that is what? Squared. Minus the little r is 0 squared dx. Why is little r 0? Because there's no inner, we don't have like a second function like in here and have a little inner radius. We don't have that. So it's just 0. And so there it is. We can simplify this one step. Pi integral 0 to 5. You multiply this times this, be x to the 2/4 dx. You don't need the 0. And that's the answer. So that's pi x to the 4th. Remember, make sure you put the pi in there. I should probably, let's do this. Let's just stick the pi's in there so you don't forget them. So there it is, pi x to the 2/4. You reduce that to be a half. That's the setup. You could easily integrate that now by hand. You could do it on Desmos. We're not going to go any further. They only want the setup on this one. So there we go. Now, why is this forming the right? Pi r squared minus little r squared. It's because it's the radius of a washer or a disc. Yeah, well, washer. So if you take a washer and it's got an well, that's not the best thing. It's got an outer and inner radius. Sorry, I'm kind of changing my mind. So if you have a washer like this, outer radius is capital R, inner radius is little r. What's the area of that washer? It's going to be pi capital R squared minus pi little r squared, right? Because you've got the outer radius and then subtract the inner radius, outer minus inner. So that's pi capital R squared minus little r squared. That's where it comes from, times the thickness. And what's the thickness? Well, you can see on the diagram, the thickness here is dx. That's how thick it is. That's the thickness. So the volume will equal that times dx. It's the area. It's the flat area of the washer times the thickness. That's why that formula is true. That's the volume formula for the washers. And so there we go.